Good morning, Math 1. So today we're going to be looking at graphing exponential functions. There's two different types of things on this worksheet. So the first type of thing is where you're going from an equation to a graph. And then the second thing that we'll be looking at is going from a graph to an equation. I've written up some examples for us to look at in this process. If we look at example number 1, we have 5 times 1/3 to the x power. I've told you guys before that writing a table, so having an xy table, is probably the most helpful way to do this because it actually shows you which points to plot so that you can connect the dots and have your graph. So just your standard xy table, t-table, whatever you want to call it. Because this is an exponential function, we're going to be having graph on the positive and the negative side of the x-axis. So let's try some negative numbers also. If we look at -3, -2, -1, 0, 1, 2, and 3, we should have a good range of outputs to be able to connect the dots. So when we plug -3 in for x, we end up with 5 times 1/3 to the -3. The negative sign just tells you to take the reciprocal. So if you take the reciprocal of 1/3, you get 3/1, which can just be written as 3. So now we have 3 to the 3rd power times 5. 3 to the 3rd power is 27. So we have 5 times 27. And then when we multiply those two numbers together, we get an output of 135. Since our y-axis only goes up to 20, that's not going to fit. So then we try -2. Just like the -3, the negative will flip our fraction, so it'll say take the reciprocal of 1/3 and we get 3 to the 2nd power. So 3 squared is 9. So now we have 5 times 9, which would be 45. And that still won't fit on our graph. So let's try -1. So the negative means take the reciprocal of 1/3 and we get 3. So now we have 5 times 3, which equals 15. That will fit on our graph, so let's plot it. So we go over on the x-axis to -1 and up on the y-axis to 15. So next we plug 0 in. Any number to the 0th power equals 1. It doesn't matter what the base number is. If it's to the 0th power, it equals 1. So we have 5 times 1, which just gives us 5. So we plot that over 0, up 5. Next we plug in 1. So we have 5 times 1/3, which would be 5/3, which is about 1.67. So if you try to graph that, you go over to the right 1, up just a little more than 1.5. When we plug in 2, so the 2 means you square both numbers. You square the 1 and you square the 2. The 3. So we end up with 1/9 times 5. So that would be 5/9, which is approximately 0.56. So when you plot that, it's just a little more than half. And then try 3. So the 3, the cubed goes to the 1, and it also goes to the 3. So we end up with 1/27 times 5, which would be 5/27, which is approximately 0.19. So I'd say go to about 1/5 on your graph. So now we have enough points that we should just be able to connect them with a curve. And we get something like that. It's just a rough sketch, it doesn't have to be perfect. For number 2, we're going to be doing something similar, but then after you've done your multiplication, we are told to add 1. So again, make your XY table. It's the most helpful way to start these problems. I would suggest using negatives and positives. So -3, -2, -1, 0, 1, 2, 3. When you plug -3 in, so now we have 3 to the -3. The negative means you take the reciprocal. So just like 1/3 we took the reciprocal and we got 3, we're going to be taking the reciprocal of 3. So 3 over 1 would be 1/3 to the 3rd power. And then multiply that by 2. So we have 1 cubed is just 1, and then 3 cubed is 27. So 2 times 1 over 27 would give us 2 27ths, which is approximately 0.07. So that one's going to be kind of hard to try and get on the graph. I would just draw it really close to the x-axis. So now when we plug in 2, we have 1 squared is just 1, 3 squared is 9. So we have 2 divided by 9, or 2/9, which is approximately 0.22 repeated. So just as best as you can, that's about 1/5 of the way above the -2. Plug in -1, so now we have 2/3, or 2 divided by 3, which is approximately 0.67. So that's going to be 2/3 of the way above the -1. Plug in 0. I've been forgetting to add 1 to all of these. That's rough. So then plus 1, that should be 1.07. Plus 1, that should be 1.22. So these are all just going to move up. See, this is why we need to read directions. Those all just moved up 1 unit. So plug in 0. Any number to the 0th power is 1. So we have 2 times 1, which is just 2. Plus 1 is 3. So we get a y-intercept of 3. From here you plug in 1. So 3 to the 1st power is 3. Times 2 is 6. Plus 1 is 7. Plug in 2. So 3 squared is 9. Times 2 is 18. Plus 1 is 19. So it looks like if we plug in 3, we're going to go off the graph. So let's not worry about even plugging it in. So our asymptote's going to be at y equals 1. So our graph will never get smaller than y equals 1. And then we connect the dots as best we can, and we get something like this, where it just runs along the y equals 1 line. So if you wanted to draw on the asymptote, you could just do a dotted dashed line, whatever you want to call it. For number 3, write the equation of the graph. So this time we're going from a graph to an equation. Again, just like when we were graphing, it was helpful to do the table. So look at all of your different inputs. We have an input, so there's a dot here, we have an input at -4, and the output is at 16. When the input was at -3, our output was at 8. When the input's at -2, the output is at 4. When the input is -1, our output is 2. When the input is 0, the output's 1. And then it looks like if we input 1, we get an output of 1/2. And the rest of them are kind of hard to see. So how do you think this is growing? Look at the growth. The easiest way to calculate the growth is you take the next term and divide it by the term previous. So if you took 8 and divided by 16, it would give you a growth of 1/2. So just to check to see if that's really your growth, you could take 2 and divide it by 4. So take the next and divide by the previous. We get 1/2 again. If you keep doing that, you're going to see that your growth is 1/2. You keep getting 1/2. It only works if you do the numbers that are right next to each other. So our format is y equals a b to the x. A is your starting point, or your y-intercept. B is your multiplier. So we know our multiplier is 1/2. The y and the x always stay the same. We need to find our y-intercept. We need to find our starting point. So it looks like on the table, on the graph, the y-intercept is at 1. So you could write the 1 in there, or you could leave the 1 off and just say it's 1/2 to the x. So either one of these answers is correct. Thank you for watching. I hope you are having a swell day.